Presentation discusses NPV and other investment rules. Sometimes these are called investment criteria or decision criteria. So those are all kind of synonymous. And different books and stuff will use different terminology for this, but these are often sometimes called decision rules or decision criteria or investment criteria. The reality is, right, this is a toolbox, right, of techniques, right, to consider potential projects. Now, this chapter has a lot of, or I'd say, math to do, techniques to learn, practice, familiarize yourself with, and then, work with, and that sort of thing. So most of the, credit here in this area is going to be devoted to, using these things correctly. But we also have some conceptual things to point out as well, about when certain criteria or rules, which one of your tools in your toolbox is appropriate for this or not for that. And so the point of the presentation here is to let you hear it from me, some of the important concept things regarding these techniques, but then also to talk a little bit about the techniques. And as always, we're trying to distill things down a little bit in a way that kind of shows you some emphasis of what's most important and what's less important from, say, our written chapter. But as always, the full written chapter is available, and additionally, you have plenty of practice type exercises that you can do, plenty of payback problems or net present value problems and stuff. You can work and execute on these things a good bit as well. So keep that in mind, of course, as we are doing our presentation here. Our capital budgeting has a focus that's long term. In fact, so one thing that you might want to keep in mind explicitly, I think our book is kind of on the ball with the idea that you need a framework, you need a horizon of more than a year, say, to be a long-term decision. And so we're not talking about something that's all wrapped up, within 1 year. So so one thing to write down or keep in mind is when we say long-term here, we're sort of basically saying like more than a year. We're dealing with in capital budgeting, we're dealing with cash flows that are expected to extend past just a year. These are big projects. We're not talking about what color stationery to order, in the new Tupelo branch or something. We're talking about things that we're on the verge of doing or not doing. And usually, if you're thinking of an idea, like a generic idea of a project, right? So you'll often hear the vocabulary word projects here. A project is kind of like a widget for an economist. A widget is just a generic term for like something that is assembled, for example, in a manufacturing plant. Projects are the same way. A project is just a generic type term, meaning, hey, some big important thing that we're going to do that we might or might not do. And I tend to think of things like opening a new factory to manufacture a new product. That's the kind of, it's a big decision, costs a lot of money, has a long time horizon. Should we do it or not? And we have tools in our toolbox like payback period, NPV, IRR, MIR that are going to help us make the right decision regarding a project. Mm-hmm. Estimating the cash flows, inflows, and outflows of a project can be it's its own topic. I mean, it's its own big piece of effort and work and stuff. So here in this area, in this chapter, this presentation, we're going to mostly be dealing with situations where the cash flows are kind of given to us. They kind of fall out of the sky, if you will, from like from a textbook that wants us to see if we can get a problem right. But practically speaking, actually estimating cash flows, inflows, and outflows in order to help make the decision is a big part of the work. right? So, right, and the same is true with the next step here, discussing your project cost of capital, right? We'll just kind of have it given to us right now in this chapter as we're working together in this presentation to demonstrate some things. But the reality is that sometimes it's a lot of work to actually come up with our own estimate of cost of capital. So that's something that we'll want to discuss in its own right. Finding the NPV, IRR, and or MIRR, those are the actual tools of the toolbox. So we want to emphasize those, and you'll have plenty of practice of doing those things for points. Be graded on them eventually. And at the end of the day, you have to make a decision. Are you going to do your project or not? Right? So when we come to the idea of a project, the bottom line with a project is usually that you're going to either accept it, which means take it on. Usually it has an upfront expense, but projects to make cash flows for you in the future, or you can reject it. Right? Are you going to accept this proposed project, or are you going to reject it? Accept it, reject it, accept it, reject it. And these tools in your toolbox, payback, NPV, IRR, MIR, are tools used to help make that decision. Some terminology to kind of help, vocabulary terminology to kind of help, hash this stuff out. You need to know what it means for a project to be independent or for projects to be mutually exclusive. And these things are not perfect opposites. These are not, opposite sides of the same coin. You can have projects that are neither independent nor mutually exclusive. So just because these terms are on this slide doesn't mean that they're like, yin and yang kind of thing. Projects are independent when knowing about project X tells you absolutely nothing about the cash flows of project Y, and simultaneously knowing something about the cash flows of project Y tell you absolutely nothing about the cash flows of project X. If you have any information about project X based on the cash flow estimates of Y, or vice versa, then projects are not independent. A different type terminology thing here is mutual exclusivity, or projects that are mutually exclusive. That means that you can only do one of the projects at most, right? So a fancy way of saying that is if acceptance of one precludes acceptance of the other. Right? So if you had 3 projects, A, B, and C, that are mutually exclusive, that means you could choose to do project A, or B, or C, or none of them, but you can't do A and B, or B and C, or A and C, or all A, B, and C, because when projects are mutually exclusive, doing one means stops you from doing any more. Sometimes this is the case for reasons like space, literal real estate kind of space, or square footage kind of space. Sometimes mutually exclusive projects are mutually exclusive because of cost, that we can only afford to do one of these things or try one of these things now. Right, so that's kind of the thinking that we used to introduce that. And then a little more vocabulary here. Projects are normal if they have outflows or costs in the first year and a series of inflows later. Right? Projects are non-normal if one or more outflow occur after the inflows have begun. This is kind of your book's way of saying this, and the shorthand is basically true, but I need to give you a little bit more detail about this. Right? Let's do it via example. If you have a project with cash flows that are, say, negative 100, and then 40, 60, 70 kind of thing, these are normal cash flows. They're normal because the upfront cost is negative. Usually that's how projects work. It takes some money to get them off the ground. Right? And then the sign changes. We go from negative to positive and we start having inflows. This is the most standard normal cash flow setup. This would also still be normal, though, if I had negative before they turn positive, or even more negatives. But what I can't have is have the sign change more than once. Right? So if I have a final one out here, if I have a final cash flow that's, say, 20, right? Negative 20, excuse me. Right? Then the sign changes again here And now I have non-normal cash flows because I had the sign change from negative to positive here, and then positive back to negative there. It's that competing, that multiple changes in sign that make a cash flow string non-normal. And now that you understand what that means, we'll have some specific reasons coming up here, why that would be a thing that might or might not matter. And here's an example, right? Book example with just cash flow data here. Now, see, the gist of this is when you look at this right away, oh, this costs some money up front, but it's going to make me money in the future. Is it worth it? Is it worth it to do this project? And by the way, we're going to have an interest rate of 10%, and we'll start using that here momentarily, really quick. Right? The first kind of analysis we're considering here in this presentation is the payback period. Well, the payback period just answers how long, as the name would imply, does it take a project to pay back for itself? It's a type of break-even analysis. How long does it take to get all your money back, to break even? So you can just keep a running tally of how this project is doing. This would be an example. I said we'd use the terminology pretty quick. You can do this sort of thing when your cash flows are normal. Right? And these are normal cash flows, right? The sign changes once between 0 and 1, but never again. If you had non-normal cash flows, right, something like this, then you have a problem, because with non-normal cash flows, you cannot use the payback period. The project might pay for itself in year 1, but then fall back to a negative overall impact in year 4. And that's kind of silly to say that, well, it pays for itself in a year, but not in 4 years, sort of thing. So normal cash flows, right, for payback period, we need normal cash flows. And once you establish that you have normal cash flows, things aren't so bad. Right? Normal cash flows, right? Just keep a running total. Right? This slide calls it cumulative. Sometimes when I'm doing it, I call it the balance. Like, what's my balance? Well, my balance is minus 150, but when I add 15 to that, my balance is now minus 135. And when I add 90 more, my balance is negative 45. And of course, this thing eventually pays for itself. Well, you can tell that just looking at it, right? Because if 150,000 is the cost, 15 plus 90 plus 120 is more than that, right? It's about 225, yes? Right, well, how long does it take this to pay for itself? When you answer that, you're answering the payback period. Right? And the way that you get it here, right, I'll write it down with you even a little bit if you want to have it. You can kind of see it just from the the slide, and you probably might realize how to do it without even being able to formally describe it, right? But the integer or whole number of the answer, remember this is all for the payback period, is the last period with a negative balance, or cumulative, or whatever you want to call it. Right? So in this case, the last time the balance is negative is time 2. Right? So the answer is going to be 2 point something, which makes sense, right? Because it had not yet paid for itself in 2 years, but in 3 years it does. We'll just say years for now at least. Right? So the answer has to be 2 point something. That's pretty obvious without even knowing formally how the rules here work. Well, how do you get the decimal part of the answer? Right? The decimal part of the answer, right, take the last negative balance, right, take its absolute value, right, and then divide that by the next period's inflow. Right? So in this case, the last negative balance was negative 45. It was at time 2, so the next period, time 3's inflow is 120. Right? So the right answer here is negative 45 over 120. Right? But it's not negative because it's the absolute value. So 45 over 120 is about 0.375, and that's the answer that you're seeing on the slide, and that's the reason you're seeing the answer on the slide. The great thing about the payback period is people do it all the time, even in household finance, so it's really kind of easy to understand. People get the idea that, oh, this pays for itself in such and such years. Right? But the big weakness, and you're going to want to know, say this is something like concept-wise, you definitely want to have ready to answer, say, a graded question. There's no time value of money being recognized here, right? And after the cash flows, after it pays for itself, it doesn't matter whether it stops immediately and you've just broken even, or whether this thing goes on to make you billions and billions of dollars a year past that. It wouldn't matter, because once the thing pays for itself, you're done calculating your payback. Right? So that's issue 2 here, ignoring the cash flows after payback. And issue 1 is, we know that dollars, say, a year from now are not worth $1 today. They're effectively worth less. Right? So negative 150,000 was your upfront cost here, but you're now acting as if dollars at year 1 and 2 and 3, you're acting as if those future dollars are perfectly able to offset, right, cash flows spent in year 0. Well, they're not. Right? We're acting like they do back here because you're recovering your minus 150 with these dollars here that are later in the future. Right? So that's a problem. That's a problem. And right, the reality is there's ways around this, things like doing just the present values of all of these cash flows and then recalculating your payback period. But there's a reason, right, that this interest rate that was 10% here that we were staring at on slide 6, we didn't use it. Not yet with the payback period, because that's one of the payback period's weaknesses. It does not take into account the price of borrowed money, the interest rate. All right. So do we use payback? Sure. I mean, companies do it all the time, even recognizing its weaknesses. Right? It can be an interesting thing to keep in mind, a factor, if you will. So it's a tool in our toolbox, and it's very easy for people to get around, wrap their head around, and understand, since it happens with household financial things all the time, right? But it's not the primary criteria you would ever want to consider, right? You could be in a case where you have one project that has a payback period of 2 years, another that has a payback period of 5 years, and the 5-year payback period might actually be the better project, even though it takes you longer to get your money back. Why? Well, it could just be something like the 2-year project. When it's done, whereas the 5-year project continues to make you profit for a long, long time. Right? So it's not enough to just know the payback period, although it's something very interesting that people can wrap their heads around quickly. What's something we would prefer that you use? The net present value. The net present value is probably the primary decision criteria, the number one tool in the toolbox, if you will. Right? With the idea being that, hey, now we are going to take time value of money into account. We're literally going to get the present value. That's the reason it's called the net present value. We're going to get the present value of all of the cash flows tied to a project. And when they're all in present value terms, these cash flows, you can throw them all into one soup, right, at the same time, and correctly have dollars from time 6 balance out dollars from time 2 or time 0. Right? So the idea with that present value is get the present values of each cash flow and just sum them all up. Costs will be negative, inflows will be positive, and let's see what happens. Does this thing make or lose present value when you factor everything in together? Right? Sometimes if you have a starting upfront cost, like cash flow, then you would think of it more directly this way, right? But these two formula are actually the same. They're just based, see the ticker here underneath the counter, underneath the sigma is the difference in this case. But keep in mind, when you're dividing by 1 plus k, like k is, say, 10% for this example that we've seen, the 0.10, the t is the time period, right? So t0 means this entire exponent is just 1, which would be this entire denominator is just 1, because anything raised to the 0 power is just 1, right? Which is a long way to say that, hey, there's a reason that the CF0, that you don't have to, right, that you can think of it as separately as its own thing, and it does not need to be divided by 1 plus k. Every other cash flow, you just take into account what period it occurs at. So if you're talking about, say, $90 at time 2, you would divide $90 by 1.10 squared, right? because that's how many periods, 2 away, your $90 is in that case. It's probably easier to just see this sort of thing via example, but it's also, say, common to at least provide something in words. Right, so the present value of future cash flows discounted at the firm's cost of capital minus the initial outlay, right, is a more formal way of talking about NPV, like what is this sort of thing. It's also just notice the change in shareholder wealth with a project. Right? The NPV at the end of the day is the reason that you do or don't do a project. Right? If you're going to choose which project to do, right? So if I say something like the most important, it's the most important criteria or rule, tool in our toolbox. The most important rule is NPV, right? And a big part of it's the only one that we measure in dollars. Right? Payback was measured in time. So it's the one to use to choose. Right? Which project, if any, to do. But the NPV, right, is the perfect tool for this and the primary one because it actually shows us the change in wealth of our company. Right? And it does so in present value dollars. So if the NPV of a project is $100 million, then doing the project makes our company $100 million more valuable, which is something you'd like, right? It would be something good if you're in management or, right, CEO, CFO, or if you're on the board helping to make these sorts of decisions. Right? NPV, the primary rule for that reason. Here's what I'm talking about in terms of getting, right, everything together into the soup. Right? The upfront cost, negative $150,000, was your original outlay. It doesn't need to be divided. It doesn't need to be changed into present value terms. It's already in present value terms. It's $150,000 spent today. That's what the time zero means as well. Right? Future cash flows, you either need to discount them using, I tend to use the direct method. I tend to do what this slide is saying, which is if I had this exact case, this example here on your slide, on my calculator, I would literally type in 15,000 divided by 1.1, and I would get this number. It's 13,636.36. And I would take 90,000 divided by 1.1 squared and get 74,380.17. That's the way that I personally find to be quicker, right, when doing this kind of thing the long way by hand. Right? Now we're going to teach you an even shorter way in a moment. Right? But you could also use the solver on your time value of money calculator too. You could say that your N, for example, is 2 and your future value is 90,000. What is the present value if the interest rate is 10%? Well, 74,380 sort of thing. Right? So again, this is kind of taking some of what we've done before with time value of money into the next level. It's even faster, and of course the idea, by the way, is projects that gain money, we talked about accept versus reject earlier. Projects that look to add value to your firm, to make you more valuable, are what the company wants. It's what the investors want, right? Because it's going to be the thing that makes us more valuable. Eventually, you'll probably be able to be paid higher dividends, for example, because of the profitability of your new project. Right? The higher the NPV, the better with the project. If the NPV is positive, then it's a good one. It's one that we want to do and we would accept, right? And the other choice, again, remember, is if you have an NPV less than 0, then you fail to accept or you reject doing your new project, kind of thing. We got different syntax here for the different NPV calculations. This is a weird one, and it's the kind of thing you can, we have some demonstration stuff up too, I believe, on the site, but we also say you can always use outside sources. If you like somebody else's video better than me, you can watch somebody blink on the buttons on, right, social media channels sort of thing instead. The syntax on the graphing calculator is kind of weird. We've done NPV before though, so it's not going to be a big surprise to you. So I hit the apps button, the number 1 for finance and the number 7 for NPV. And then we've talked about this, setup before, but the commas here are really important. The rate comes first, but it comes in percentages. You don't have to put 0.10. You can just do 10 because you're in your time value of money portion of your calculator where rates are seen in percent form. You have to use the braces here instead of the parentheses, blah, blah, blah. But your NPV in this project is 28,174 and 31. That doesn't surprise me that this NPV is a good one, and this is then a product you would accept, because when you're looking at this kind of setup, and you'll get better at this the more you practice, this thing returns $225,000 within just 3 years. That's a 50% return, right? Minus 150 versus positive 225. And that's a pretty big return. Now, if the big return was backdated many, many, many years in the future from now, it might not be, right, the kind of project you'd want to do. Your NPV would be potentially negative, but that's probably not going to happen with only 3 years into the future, sort of thing. So you'll when you practice this, you'll have a pretty good eye pretty quickly for which ones are likely to be positive or negative projects. You can do the same thing with the BA2 that we've talked about before. It's getting your net present value via the cash flow register on your calculator. You just need to be careful, right, with making sure that the calculator is clear, right, that you remember to hit NPV when you're finally done inputting cash flows. You're going to have to put an I in for as an interest rate. Hit enter one final time, scroll down, and hit compute to get the final answer. So all the directions here are kind of laid out, but just a reminder that you want to practice the calculator syntax on this. I personally am not an HP 10B guy, but it's a pretty quick and easy calculation to do here in this case. Okay, we also have an example here to kind of illustrate how you can use the frequency buttons on your financial calculator to help you with this sort of input, something we've also discussed before. You don't have to use this shortcut or extra trick, but you're welcome to if you're comfortable doing so. Right? So for example, right, if you have 15,000 3 times, 90,000 8 times, $120,000 6 times in a row, and they genuinely are coming in a row, rather than doing one set of braces where you type out every cash flow, like in this case I have to do 15,000, 15,000, 50,000, 90,000, 90,000, 90,000, 90,000, 90,000. I got to do 8 of them, right? And then 6 of the 120s. Rather than typing all that out, when you have these repeating numbers, you can close your first set of braces, hit a comma, it's a necessary one, open a second set of braces, and have the numbers inside match up with the frequencies of the individual cash flows. So since 15,000 is the first cash flow and we want 3 of them, we type in a 3. Then 8 90,000s and 6 120,000s. After you're done with that, you're still going to just close your parentheses and hit enter. Right? Whereas if you're on a BA2, I actually think the interface is probably even friendlier to let you know to use the frequency shortcut, because as you scroll down after entering these pieces, the calculator kind of automatically is set to ask you how many. It'll say FO, like O, 0, like frequency 1. How many 15,000s do you want, for example? Well, I want 3 of them. All right. Well, that's the reason for the 50,000 or 500,000, excuse me, negative. 15,000, 3 of them. 90,000, 8 of them, and such. Right. It makes for actually a pretty more natural flow, I think, inside of the calculator. Right. And the 10B2 is not that much more difficult either. It's also pretty direct in terms of allowing you to do a repeating payment amount type of valuation. And kind of like we discussed the last time that NPV was a topic, just practice. I mean, practice is the sort of thing. You're going to have a calculator that you're comfortable with, and it's just one of those things that you need to be able to do. And say it's generally speaking, if you've done 2 or 3 of them, you kind of get the flow down pretty well. Sure, there's syntax errors you can make, like with the braces and commas here with your graphing calculator, or sure, there's other problems that you could have, run into, etc. with if you're forgetting to do your cash flow register. But that's why practice is kind of the key. The internal rate of return is actually the very akin to the NPV. It's one of the other tools in your toolbox. But internal rate of return is a rate, right? It's right there in the name. Internal rate of return. Right? So IRR for short, internal rate of return, right, is measured in dollars. Okay, measured in dollars. I can't believe I just said that. Blech. Sorry, folks. I have my brain on autopilot. It's measured in percentage, right, or proportion. Sorry, that's the whole point. It's not measured in dollars. NPV is, right? It's an internal rate of return, right? It's the exact weighted average cost of capital, or K, in your slides here. It's the exact level of cost that would make NPV equals 0 for the given cash flows. Right? So it's very much tied to NPV. NPV and IRR are pretty darn linked, if you will. They're pretty linked together. Right? The IRR is the exact cost, the discount rate that you'd have to get an NPV of 0 when considering your cash flows. But a bit of I kind of like this explanation a little bit more, so I'll share it with you as well. Right? I use this one in some other classes. And the IRR, right, is the cap or ceiling, right, on how high the costs, and I'm saying costs as a rate, and in particular your WACC or your K in these slides, like K in this book, right? How high costs can get and still have an acceptable project. Right? So what do I mean? Well, what if you had an example, something like, if the costs are 7%, right? And let's do an IRR of 11. Nah, we'll do 10. IRR, heck, we'll do 9. IRR equals 9%. So if your costs are 7%, if your K equals 7%, then, right, your NPV is going to be positive and you're going to accept. If your K is 8%, same deal. Your NPV is going to be positive, accept. Right? But once you get to 9, now you have the magic number where your NPV is no longer positive. It's exactly 0. That's the whole point. That's what IRR is. Now, the reality is, I think our book especially says that you should go ahead and accept projects when the NPV is exactly 0. I'm not so sure about that. It's practically speaking, it's not going to happen. You're going to be dealing with millions, billions of dollars, and you're not going to have an NPV that's exactly 0.0000. Right? But that would still be kind of an acceptable based on the ground rules of our book. Right? But you get even slightly above that, right? If you have K equals 9.02%, right? Now your NPV is negative, and you're supposed to reject. Well, you would reject, right? Because again, NPV and IRR are linked at the hip in this way. Now, that doesn't mean that you should ever use IRR to choose between projects. Right? And that doesn't mean that IRR is as important a decision rule as NPV. Right? But you learn very similar information about projects, whether in terms of them just being acceptable or not, by doing IRR as you do NPV. Right? It doesn't tell you anything about the scale of the projects, right? You can have a project that's acceptable, right, but makes not really that much money. Or you could have another one that's acceptable and has the same IRR, but makes billions and billions and billions of dollars. Right? So all that we're really talking about, the only real information you get in the IRR is when you compare, right, your IRR to the WACC. Right? You don't use the IRR, the WACC, excuse me, you don't use the WACC in the calculation. It's not part of the calculation. Right? Not part of the calculation. Right? It's just a comparison at the end to consider this accept-reject dichotomy. All right. Trying to think what else to say about this. They say, again, this case where the IRR meets the WACC or the K, again, I use this, WACC is to me the little bit picture this book likes K. This is never going to practically happen because you're talking about literally to the exact dollar amount an NPV of 0. Right? But when your IRR is bigger, right, than your costs, that's a good thing. That's an accept. That means you're going to have, right, a return. Say a different way of thinking of it, you're expecting a return bigger than the expectations required by shareholders. That's the reason that the NPV is positive and you got an acceptable project, right? So if your projects are independent, right, here's the rules again on another slide. Say I like the ceiling or cap idea. Hey, as long as you can keep the cost below this, you're going to have a positive NPV. I like that kind of extra piece of interpretation along with accepting based on the IRR sort of thing. The actual like keystrokes in a calculator to do IRR are really similar to NPV. If you got a TI graphing calculator, it's in the same area. It's the apps button, then 1 for finance, right? But number 8 is hidden. The first 7 things are on the screen for all the models that I'm familiar with, but 7 is NPV. It's in the last row, and you can't see unless you scroll down that the 8th function is IRR. So you just kind of have to learn from like somebody like me telling you, I guess, that you hit number 8. So you hit apps, 1 for finance, 8 for IRR. It'll give you IRR in the first open parenthesis, and then you have to type in, right? So this is the same example. You have to type in everything. Still using this comma here is a bugaboo that a lot of students will forget as they're getting new. They're getting to this when they're new. The braces thing, instead of parentheses, using braces can screw with people on financial calculators for IRR. But the IRR is really, this is really similar to the NPV, right? Doesn't this right here look really similar to this calculation here? Yeah, it does. Whoops, this one here. Yeah, it does. The only difference is IRR is a little easier. You don't need to put in the K. You don't need to put in your cost of capital, comma, to start. You get to start right with the negative 150,000 sort of thing. Right? So the IRR is actually easier. Right? Well, that shouldn't be a surprise, right? Because the whole point of IRR is you don't need the WACC, the K, as part of the calculation. Right? Instead, with the IRR, you take your final amount, your final finding here is an IRR of 18.13%, and you use the WACC as a comparison metric. So when 18.13% is larger than 10, that's an acceptable project because it comes with a positive NPV. Yeah. Right, so really similar with the BA2 Plus. It's just when you're done, you don't have to hit the NPV key and enter a rate. Right? Because again, you're just using the rate as a comparison metric here. You can just hit IRR and the compute key and you're done. Right? And just same thing with the HP. The actual calculator keystrokes are shorter here this time. You can use the same shortcuts, right, with frequencies as well when you're doing IRR. The same frequency shortcuts that we did with NPV. So for example, with this 500,000 and the 15,000 3 times, 90,000 8 times, 120,000 6 times, this typing right here on slide 29, that's the exact same calculation that we did here on slide 19, right? It's just that you get to omit the 10 comma. You get to start with IRR, open parenthesis, right, before you type in your values, kind of thing. I didn't say, and there is still, it is pretty finicky. You do have to be careful with braces, with commas, et cetera, et cetera. That's the reason that practice, practice, practice is absolutely necessary here. With the BA2, right, it'll prompt you as you're scrolling down with these down arrow keys. It'll prompt you with at the F. The F stands for frequency, and you can very easily say, oh, well, there's 3 15,000, so I enter my 3, and there's 8 90,000, so I enter my 8, and so on, right? And you can again say check your work and do some practice problems with us too to make sure that you indeed have it down, right? Finally, there with your HP calculator. NPV and I are, say, you heard it from me already, right? NPV and I will give you the same information about independent projects, right? That is to say, if all I'm thinking about is this one project, project X, right? I'm going to get the exact same decision, accept the project. I'm going to get the same idea, accept it, whether I use IRR or NPV. With NPV, I'll get that accept, right, decision because the NPV is positive. With IRR, I'm going to get it because my IRR is greater than my K or my costs, right? But those things themselves are linked, right? The NPV is positive when the IRR is larger than the cost. So you're getting the same information when you're talking about independent projects. Now, this comment at the bottom, though, don't use IRR to choose amongst projects. You don't want to rank which one is best because IRR only considers things in terms of rate. It's measured as a percentage or a rate. It's not measured in dollars like NPV is. So you can actually have a project, right? You can actually have something like this dichotomy where project X, right, has an NPV of 70, right, and an IRR of 12%. And project Y has an NPV of 80, but an IRR of 11%, right? Well, this is the superior project, right? This is the one that you'd want to do if you were ranking them, right? Because it has the better NPV, and that's the only decision rule measured in dollars, right? And so it's the one that adds the most value, and that's ultimately what we care about. But it also has a cap that's harder to meet. The IRR is lower for costs, a cap that is harder to meet than excess. But say that's because IRR is paying no real attention to the size of the project, right, when it spits out an answer because it's measured in rate, not in dollars. Right? You can also you can't use IRR with non-normal cash flows. So if you had something where, for example, you had an upfront cost, 10, 60, 80, and then you had another like cleanup cost at the end, well, now you can't do your IRR because you had a non-normal setting where the sign changed more than once. It went from negative to positive between time 0 and 1, but then back to negative at time 4. Remember, I had a negative sign here, right? So IRR is not okay. You can't use it with non-normal cash flows. Long story, but that's the case. And then say we're also assuming your future cash flows can be reinvested at the same rate. That's kind of an implicit problem with the IRR. NPV is preferable in that it's always denominated in dollars, right? Though it also makes the same sort of assumption regarding the reinvestment of capital at the opportunity cost. At the opportunity cost rate. And I just kind of mangled that explanation again a moment ago, which is, yeah, your IRR is assuming that you're reinvested at the same rate of return for the current project, right? Whereas the NPV uses a certain capital. So if you have, right, a cost of capital given to you, that's the rate at which you're reinvesting cash flows here. Whereas the IRR, if you get an IRR of 11%, in terms of IRR, it's assuming that you're going to continue to reinvest at 11%, even if the WACC is 9, right? And this is another reason, say, that's a bit technical here to get into the weeds, but That's another reason deep down that you'd want to be using your net present value to choose amongst mutually exclusive products. You also, by the way, don't forget with mutually exclusive, you also always have the right to say no to them all. So if you have, say, 3 potential products on the table and they all have negative NPVs, they all project to be money losers, then you can ignore all 3. Right? Managers like IRR, right? They like rates. They're easier to understand, right, than when we're talking about things in $10 million versus $100 million. There's a lot of folks that make scaling sort of issues with that. So when you're telling tale of company performance, it's often common to want to talk about things in terms of rates returned. Right? But the IRR has some problems with it, as we've discussed. For example, that non-normal cash flows that you can't even use the MIRR to attack, or excuse me, that you can't use the IRR to attack. So this example right here, the IRR is a complete no-no, right? But the MIRR, the new method we're about to discuss, right, would actually be okay to value these cash flows. You can do this problem down here with the MIRR. It's not okay with the IRR. It is okay with the MIRR. Well, what is the MIRR? The modified internal rate of return, you would think, is a lot like the IRR. The execution, the actual work done to come up with the number for the MIRR is pretty different. It's pretty different. It's more involved. It's not just a simple one-line thing on the calculator. So while they share a name in common, MIRR and IRR, at least 3 of the 4 letters, right, in the abbreviation, they might share that. But the actual work done to come up with this formula is tricky. Right? You're trying to find exactly the rate, right, that makes the present value of all of your cash outflows, right, equal the future value of all of your cash inflows. Right? That's the reason, if you will, for the exponent here on these, right? The future part, and that versus the division of 1 plus k to the t. This is the present value part. But I think this formula is very unlikely that someone's going to stare at that formula and enjoy it or figure that that's the easiest way or the most useful way to actually do the work. So I think it's easier to list you some steps and maybe show you an example or two. Okay. This in a pretty simple nutshell, and you could of course have access to this slide or whatever you needed to. It tells you what to do in words. Get the present value of all the negatives, and you want to get the future value at the last period of all the positives, and then find the rate that makes those 2 piles equal. I always talk about these things as 2 piles. Right? So for example, if you have this project right here, and there in the second column, the cash flow column, there's basically telling you, right, look, this is definitely not normal, right? It goes from negative to positive, back to negative, back to positive, back to negative at times 6. So you have quite the interesting little project here, right? So the way to deal with this would be, say, 0, 1, 2, 3, 4, 5, 6. And I'm just going to do these all in thousands. So negative 100, 20, 40, 35, 80, 70, and negative 10. I want to get all of the negatives at time 0. So you can do that by doing your present values. You can do them manually, like by dividing by 1.10 to the 6th and 1.10 to the 3rd. And this one's already at time 0. You can do that. Or you can be clever and use your calculator to only deal with the negatives first. Right? Get yourself the net present value of negative 100 at time 0. Put in 2 zeros for cash flows 1 and 2. Negative 35,000 for cash flow 3. 2 zeros for cash flows 4 and 5. Negative 10,000 at 6. Right? So like so. And now you have a present value of all the negatives. And the NPV key, of course, automatically gives you the present value of all the negatives. How about your future value? right, of all the positives. Well, you can do the positives, right, with kind of the old school attack. You can say multiply the 70 by 1.10, and this one by 1.10 squared, right, and this one by 1.10 cubed. And that's actually not cubed, that's to the fourth, I'm sorry, because it's in time 2, it goes up 4 periods. Right, the exponent is always the number of periods the money grows, right? So times 1.10 to the 5th. You can do that, right? You can do that to get all of these and just add them all up at times 6. Or, right, you can go back to your cash flows, right, and just get the present value of all of the positives. And it says 149, 345, but you have to remember the 149, 345, 24 here is at time 0. It's not at time 6, right? And you need it, as this step 2 says, you need it at time 6. So if you're going to use the method here, right, you'd get the present value, and now you need to grow that number to times 6. Right? So you can just, right, use your solver, like n is 6, I is 10, and get 264, 574, right? Or you could also take that grand total, that number, right, and you could multiply by 1.10 to the 6th, right? And it would also give you 264, 574. Right? And then, right, the last step, find the rate that makes your two piles negative. You have a negative pile, right, at time 0. You have a positive pile at time 6. So there's 6 periods apart. That's your n. The values of the piles go in the PV and FV boxes. The PV one's going to be negative. Solve for the rate. And this rate that you solve for in your calculator is your new MIRR. So it's 12.295 in this case. Right. Now, NPV is still the rule to go with, right? In terms of having to make a decision amongst projects, ranking them or anything like that. So always keep that in mind. NPV, the only decision criteria denominated in dollars, so it is definitely our favorite, most important of all the decision criteria. But the MIR provides an additional technique. Right? It's measured in rate, which some managers like. It's usable with non-normal cash flows, which is very cool. Right? So just another alternative tool for our toolbox. Right? And all these more so than a payback period, which pays no attention to time value of money or the dollars that you're generated after a project pays for itself. All right, there you go.